thirds, right? Okay, so does anyone need me to do any one of those? And I know you can do them on the calculator. I hope you didn't though, because we're learning. Okay, so does anyone need me to do?
Excuse me, please. A representative of Miss Condon Gaffney, 6th year Ag Science class to reception now.
Anyone need me to do any one of last night's homework? Yes. Question 3, part 3, was it? No. All the part 2s, was it?
Yeah.
Okay, so it's 2 all over the square root of 8. So you can simplify 8, right, into its factors, for one of its factors is a perfect square. So, sorry, it's magnified. Right, so one of the factors is a perfect square, so you can simplify 8 into 4 multiplied by 2. So that would be 2 all over, give each factor its own square root sign. Square root of 4 all over the square root of 2. And then we have 2 all over the square root of 4 is 2. So that's 2 all over 2 root 2. Then 2 into 2 goes 1, 2 into 2 goes 1. So that's actually 1 over root 2. Is that okay? Right, any more questions from last night's homework? No, we're all good? Question 9, yeah. Oh, yeah, that's the same thing. Right, okay. What they did then was they rationalized the denominator, sorry. Rationalized the denominator, right? It's not the norm, right, to leave a square root sign underneath the line. Now, I wouldn't see anything wrong with leaving 1 over root 2. But even the calculator will not give you 1 over root 2, right? Okay, so you have to do what's called rationalize the denominator, which is what the one thing I didn't do on Friday, I didn't get to it. Okay, so rationalize the denominator, you multiply above and below. Rationalize the denominator means get the square root sign out from underneath the line. So you can have it above the line, but you can't have it below the line, right? So if you multiply above the line by root 2 and multiply below the line by root 2, right? Okay, why root 2? Because that's what's underneath the line, okay? And you're multiplying by root 2 over root 2, so you're basically multiplying by 1. So you're not changing it, you're not? Okay, so on top you have 1 by root 2, which is root 2. On the bottom you have root 2 by root 2. They're both under square root sign, so you can multiply the two of them. Right, and put the answer...
Excuse me, please. Mara Matarin to reception now.
You can put the answer under the square root sign. So that's root 2 over 2. Okay, right? Is that right? So 1 over root 2 and root 2 over root 2 over 2 are the exact same thing. Right? Are we okay? Right. Someone asked me for number 9, yeah? Okay. So number 9 reads, show that 2 root 5 minus 3 root 2 multiplied by 2 root 5 plus 3 root 2, right, and show that when you multiply, so the answer is going to be 2. So it's basically multiply them and show me the answer is 2. So split up the first bracket, 2 root 5 multiplied by the second bracket, 2 root 5 plus 3 root 2. Then the rest of the first bracket minus 3 root 2 multiplied by 2 root 5 plus 3 root 2. So split up your first bracket, write your second bracket down twice. Okay, remember you can multiply regular numbers, and if you have two things under a square root sign, right, that's never a phone error. It wouldn't be, because you're in 5th year. That just would not happen, right? 2 by 2 is 4, and then that's under square root sign, that's under square root sign, so you can multiply them and put the answer under a square root sign, right? Or you can say root 5 by root 5 is just 5, okay? Here, 2 by 3 is 6, root 5 by root 2 is the square root of 10. Okay, over here, minus 3 by 2 is 6, and root 2 by root 5 is root 10. And here, a minus by a plus is a minus, 3 by 3 is 9, Root 2 by root 2 is root 4. Okay, they cancel, it give me 0. 4 root 25 is actually 4 times 5. And the other one over here is 9 times root 4, root 4 is 2. So 4 times 5 is 20. Take away 9 times 2 is 18, which is 2. And that's the answer they said I should get. Is that okay? Any other questions for me? Right, so I just have one little bit to do in this, okay, and it's called, just what I just did there a minute ago, it's called rationalizing the denominator. So the denominator is what's below the line, and rationalizing means we get rid of the square root underneath the line. And again, you can do it on the calculator, okay, but the calculator will always give you the answer without a square root under the square root sign. I think, would that be right? I think it does, right? Okay, so that means no square root underneath the line. Under the line, no square root under the line. Right, okay, for example, right, if I have 5 over root 3. Okay, so it's not the norm to give a square root underneath the line. Okay, right, so you multiply above and below by whatever's underneath the line. So multiply by root 3 over root 3. So you're effectively multiplying by 1, because root 3 over root 3 is 1. Right, so above the line I'll have 5 root 3. Below the line I multiply the numbers and put the answer under a square root sign. So that's 5 root 3 over 3, and believe it or not, that's a better version than that. That's a more simplified version than that. Okay, because it's called rationalizing the denominator, because there's no square root sign underneath the line anyway. Right, and if you were to put that into the calculator would spit this back at you. Right, because the calculator will always rationalize the denominator automatically. Is that okay? Right, so a bit of a harder one, if I had 1 all over 7 minus root 2. Okay, so when there's a rational bit and an irrational bit, right? When there's a rational bit, as in no square root sign, and an irrational bit, a square root sign, you multiply above and below, you change the sign of the irrational bit, so multiply 7 plus root 2. And if you multiply the top by it, you must multiply the bottom by the same thing. So you're multiplying by 1 effectively. So above the line, I have 7 plus root 2. Below the line, I'm multiplying 7 minus root 2, multiplied by 7 plus root 2. So that would be, above the line, that would be 7 plus root 2. Now, below the line, split up the first bracket, write the second bracket down twice. I'll skip to 49 minus 7 root 2 plus 7 root 2. Right, okay, a bit of extra room there. Minus root 4. Okay, so don't mind that, that's gone. Is that alright? Okay, so above the line that would be 7 plus root 2. Below the line, these are gone. And I have 49 minus root 4, which would be 47. Is that okay? Root 4 is 2. So it's 49 minus 2. You can see there's no square root underneath the line. So I basically rationalize the denominator. Is that alright? Rationalize means I've made it a rational number. And remember, a rational number has no square root sign. Right? Are we good with that? Right. Can I move on to the next section? Right, okay. So I had all the other stuff on surge done the last day, I just didn't get to that. Okay, right, can I take it away? Okay, now we're coming to the reason why we were revising surge and why we didn't just do them in the calculator. Okay, can I go? Yeah, okay, algebraic surge equations. So basically there's now going to be an X in it. Yeah, algebraic surge equations. So algebraic means there's going to be a letter X, Y, A, whatever it is, right? Surd means there's going to be a square root sign, and equation means there's going to be an equal sign. So there's going to be a variable, as in a letter A, B, X, Y, whatever. Okay, there's going to be a square root sign, and there's going to be an equal sign. Okay, right, okay, rules, right? We'll write down the rules first, okay, and then I'll do them and you'll know what the rules mean. If there's only one surd, so if there's only one surd, isolated on one side, so put it by itself on one side, square both sides, and solve. So if there's only one square root sign in the whole equation, just put it on its own at one side, square both sides and solve. Right? Okay, we'll see an example of that in a minute. Right? If there are two surds, so if there's two square root signs, move one to each side, so one on the left, one on the right. And girls, if a surd still remains, repeat the first point. Okay, so that means you may have to put one surd on each side, square each side, then there still might be a surd left, so you may have to move it to one side, square each side again, and so you might end up squaring twice, that's what I'm saying. We'll see an example in a minute, it'll all make sense. Repeat first instruction. What I mean, i.e., you may have to square twice. And this will all make more sense when we see an example. So you may have to square twice. Okay? Right, example 1. Solve Okay, something like this. Okay, so there's a third here, right? Okay, so there's just one third. So when there's just one third, you put it on its own at one side and put everything else over the other side. So I'm going to leave this 2x, square root of 2x plus 1 on its own on the left. I'm going to move the minus 3 over, it becomes plus 3. Okay, so I've isolated the third on its own on the left hand side. Okay, then the next step was to square both sides, because squaring gets rid of a square root sign. So square both sides. Okay, square root and square are the opposite of each other, so I'm just left with 2x plus 1 here. Over here, 3 to be squared is 9. So then it's just x's on one side, numbers on the other. 2x is equal to 9 minus 1, which is 8, so that means x is equal to 4. Is that okay? Right? So that's just the first instruction, very simply. Right? Example 2. Let's see. Right. Square root of 3x minus 5 equals x minus 1. Okay, this one also has 1/3 and it's already isolated by itself on one side, isn't it? So I don't have to move anything around. What I do have to do is what I do next. Square both sides, so square this side and look, square that side. Okay, so you have to square them both together. You can't just square the x and square the 1. It's the whole side to be squared. So here I'll get 3x minus 5. Over here I have to square the first, twice the first by the second, square the last. So then I need to bring everything to the left. So I have minus x squared plus 2x minus 1 plus 3x minus 5 equals 0. So that would be minus x squared, the x's together, so I have plus 2x plus 3x would be plus 5x. And my numbers there would be minus 1 minus 5, which is minus 6, equals 0. I need to factorize. So I have x squared minus 5x plus 6 equals 0. In order to factorize, the x squared term has to be positive. Okay, unless I'm using the minus b formula. So then I have two sets of brackets, x and x, 2 and 3, a minus and a minus. Then I let each bracket equal 0 and I get x is 2, x is 3. Now it's really important to check your answer. Okay, it's really important to go back because they both mightn't be valid answers. So you know the way I had the square root of 3x minus 5. Okay, so I had the square root of 3x minus 5. Just in case that turns out to me trying to get the square root of a negative number, I just have to make sure that when I put in the numbers here, that ends up positive. So 3 times 2 minus 5 is the square root of 1. That's fine, isn't it? And if I put in 3, is 3 times 3 is 9 minus 5, which is the square root of 4, which is fine too. Just a quick check, because sometimes when you put in the x value, you'll end up trying to get the square root of a negative number, which doesn't exist, so you need to be able to cross out your answer and say, that's not a valid answer. So it's really important with these that you just put your answer back into the original equation just to make sure it's fine. Is that okay? Right, I'll try and pick one where... Right, example 3, I've moved that up, is that okay? So I'm going to do one with a third in each side. So if I have the square root of, wait, not let's see, I'll just go square root of 5 plus x, 5x plus 6 even, minus root 2x equals 2. So this is case number 2. You know the way we did bullet points, this was the second bullet point. There's more than 1/3, right? Okay, there's more than 1/3. Now, if you go into squaring both sides right now, right, you'll end up with crazy stuff that you will not be able to solve. So when there is two thirds, girls, you have to put one third on the left, one third on the right. So I'm going to leave the square root of 5x plus 6 on the left. Right, and I'm going to bring over that minus root 2x to make it plus root 2x. Is that okay? Right, that's what you do when there's two square root signs. What you do when there's three square root signs, you'll never be asked. Okay, you're in college now, so you pat yourself on the back. Right, okay, if you get three square root signs. Right, okay, right, so then you square both sides. So square both sides, so square this side and square this side. Okay, so when you square this side, square root sign and square just cancel. So you get 5x plus 6. Over this side, you have to square the first, which is 2. Then it's twice the first by the second, so twice the first is 4. Multiplied by the second would be 4 root 2x. Is that okay? And then I need to square the last, and square the last is just root 2x, all to be squared, so that will cancel that, won't it? Okay, so it'll just be 2x on its own. Are we good? Right, okay, so what I'm going to do is, now we're back to the first step. There's still a third, right? So there's still a third here, so that means I have to isolate that by itself on one side, everything over on the other side, and square both sides again. So, you know, that's where I said you may have to square twice. This is a case where you have to square twice. So leave the 5x plus 6 here. Bring over that 4, it's minus 4. Right, bring over that 2x, it becomes minus 2x. And I leave the third over here on the right. Is that okay? You all good with that? Right, I'm going to tidy up the left. So that would be 3x plus 2 equals 4 root 2x. What I do now, square both sides again. So squared here and squared here. So that would be square the first, 9x squared. Twice the first by the second would be 12x. Square the last would be 4. And over this side, you square 4, you get 16. And you square root 2x, you just get 2x. Is everyone with me? How that happened? 4 root 2x to be squared, you just square the number. And if you square root 2x, you'll just get 2x. Are you with me? Right, okay. I need to, that's 9x.
Excuse me, please. There will be soccer training tomorrow after school for all interested in under 14/under 15. This includes trials in preparation for upcoming matches. Thank you.
Right, okay, so that's 9x squared. When I tidy that up, that's minus 20x. Plus 4. Is that okay? Two sets of brackets, factors, 9x and x, 2 and 2, and a minus and a minus. I think I'm right. Minus 2x minus 18x. Yes, I am. Then you leave each bracket equal 0. So you get 9x minus 2 equals 0. So that means x works out to be 2 over 9. And x minus 2 equals 0. So that means x works out to be 2. Right? Check your answer, as in put it back up into the top, just to make sure that you end up getting the square root of a minus number. So if you put in 2/9, I'll be getting the square root of a positive number there, won't I? And I'll be getting the square root of a positive number there, so I'm fine. If I put in the 2, likewise, I'll be getting the square root of a positive number and the square root of a positive number, so I'm grand. Both are valid answers. Okay, it's just sometimes when you replace them, you end up trying to get the square root of a negative number which doesn't exist, so that means it's not an answer. So you need to cross it out. Do you all know what I mean when I say that? You're all okay with that? Okay. Right, now will I try and get one where it's not a valid answer? Probably isn't one. Right, I think I'll give you a few of these to do and we can iron out the problems tomorrow. Okay, so we'll do page 77. Okay, if we do question 5, I'm after doing one of those now. Which one did I do? Except part 1 and 4. So part 5, let's do 2, 3, 5 and 6, because I've done 2 of them as the examples there. So I've done part 1 and part 4. Okay, so parts 2, 3, 5 and 6, and let's do all of question 6, and let's have a look at question 7 while we're at it. Okay, is that alright? And I'll put a picture up now. Yes, yeah. I'll just move it up like that. Now, I had a phone. Okay, let's stop recording.